Hello, my name is Naomi Rodriguez. I'm going to be presenting my research on advanced analysis of Hispanic voter activity in Florida through sub-ethnicities identification. Support for this project is provided by the National Research Experience for Undergraduates Program of the Mathematical Association of America, funded by the NSF grant. So for a bit of a background, between the years of 2016 and 2018, the democratic performance amongst Hispanics went down statewide. However, between these same years, the overall Hispanic vote has increased. And keep in mind, roughly 24.7% of the Floridian population is Hispanic, which equates to around 4 million Hispanics. So this graph here is the Hispanic subgroups from the total Hispanic population in Florida through census data. So as you can see here, we have a variety of Hispanic subgroups. As we can see, we have 19 sub-ethnicities and 20 subgroups, which includes the others category. So as you can see, we have three dominant Hispanic subgroups: Mexican, Puerto Rican, and Cuban. And because we have a variety of sub-ethnicities displayed here, we know that Hispanic can be a broad term from classifying any individual from Latin and South America. And so the overall goal of this project really is to analyze Hispanic voting trends within the state of Florida to pinpoint which sub-ethnicities are over or underperforming to then increase the overall Hispanic vote. And we do know from past elections that the Hispanic vote has a large influence over not only local elections, but also the outcome of national elections, which is really important to analyze these Hispanic voting trends. But in order to begin analyzing these Hispanic voting trends, we first need to classify individual sub-ethnicities. As stated here, we are only given that they are Hispanic. Therefore, we need to develop a model and algorithm to then begin classifying which of these Hispanic subgroups throughout the state of Florida are under and overperforming. So as a starting point, we have our public voter information. This is publicly available to anyone online. So first we take our county code, voter ID. We're going to classify this as organizing the data when we start our analysis. Next, we take last name, first name, and zip code. We're going to classify this as individuals information. This is going to be a very key component as I talk more about our research. For gender, race, birth date, party affiliation, and voting status are going to be classified as are going to be used to analyze Hispanic voting trends. This is after we are going to run our analysis on classifying what subgroups the individuals will be classified as. So as you can see here, we are not given a sub-ethnicity. All we are given is race. And for many of you, especially the ones who have voted, we know that on the ballot, we are only given options such as African American, Caucasian, Hispanic, Native American, and others. So that doesn't really give us much insight into what sub-ethnicity they can be, which is and this is where individuals' information plays a large role. We are going to take the first and last name and zip code and their zip code to create a probability calculation that will tell us what this individual will most likely identify as for their subgroup. Then that will lead us to eventually pinpoint which subgroups within the state of Florida are under and overperforming. So for our supplemental data, we have zip codes, which gives us the population at an individual zip code, then the percentages of Hispanic at the given zip code, and then from there, it gives us a breakdown of which sub-ethnicities exist at the given zip code with percentages. For our first and last name, we took the top 1,000 most popular names per country. As seen in our previous slides before, we are taking that for all 19 countries. From there, we have our model. So as stated earlier, we have the individual's information: zip code, first name, and last name, and any additional last names. So we know that from Hispanic culture and heritage that many Hispanics tend to take on multiple last names. Because of that, we can utilize that to give us a more precise percentage and prediction of what that individual will most likely be classified as. From there, we take our probability calculations. So we take these sub-ethnicities percentages at each given zip code, which are 19 percentages. Then we take popularity percentages of the first name and last name and any additional last name for each sub-ethnicity. From there, we combine these percentages to create the predicted sub-ethnicity. This is going to be the most probable sub-ethnicity that that individual will be classified as. So in order to do that, we need to implement this model to all the Hispanics in the state of Florida, roughly 4 million Hispanics. So as stated before, we are taking the public voter information. We extract all Hispanics from that, along with its necessary columns and information, and organize that with the supplemental data. Then we run all of this data through our Python code. We're going to run all 67 counties through this, which will then output our results that we can then plot on a map to then really begin analyzing the behavior and trends on that results map. So what I did is I did a sample analysis of a county in Florida. I did the Calhoun County because it's one of the smallest of the 67 counties within the state of Florida. Total population of 8,737 with only a total Hispanic population of 105. So from here, we have the party affiliation distribution along with the Hispanic gender distribution. So what I did with this data is I ran it through a model, which outputted one of these few graphs. So what we have here is the probability distribution for all individuals within the zip code 32421. This is within Calhoun County. So as we see here, we can see the probability distribution of some of the individuals that reside at the zip code. And it also, this graph also tells us what sub-ethnicities do exist at this given zip code, along with its probability percentages of those individuals residing there. Next, we have the results with, what we have here is the model predictions of individuals per subgroup within the Calhoun County. As you can see here, not all 20 subgroups are stated here. So as we can also see here, our model is not overplotting except with the exception of Panamanians. So as you can see in orange is our zip code data. We know that our zip code data is our most concrete data because it comes from census data. And here in the blue, we have our model. Keep in mind, the model is including the first name probability, last name probability, and the zip code probability with a combined total. As you can see here, the model is not fully predicting the actual number from our zip code data. However, with the Panamanians, we do see an overplotting, which tells us we need to create a more precise model and algorithm so that we are not creating individuals that do not exist at this given zip code. And with this graph, we should see more consistent graphs like this after we begin implementing all the counties within the state of Florida. So as you can see here in this graphic done by the Pew Research Center, Florida's Hispanic electorate between the years of 2008 and 2018, we do see a large increase between these years, given the fact we see there are a variety of Hispanic subgroups in addition to the eligible voter population. So as we can see, we have roughly 3 million eligible Hispanic voters. And what we want to do is we want to increase this number because we know that the Hispanic vote has a large influence over a lot of decisions made in Congress and whatnot. Therefore, as a working conclusion, we need to increase the precision of determining percentages of the most probable sub-ethnicities for each individual, especially since we're going to be implementing this for about 4 million Hispanics. In addition, we need to enhance our implementation techniques, such as one of them being increasing precision. And then with this model and algorithm, we may be able to pinpoint which subgroups have an increase or decrease in voting turnout by specific regions. Although after running this analysis, we may not able to see a clear we may not be able to see a clear differentiation of which subgroups are over or underperforming, but it will still provide us a lot of necessary statistics to come to other types of conclusion, especially with the overall Hispanic population. So for our next steps, we still need to optimize the model and continue implementation for all the Hispanic voters in this given data set. And we also need to provide a measure of accuracy of prediction and reanalyze lost data. So as an example, because we created our own supplemental database, we know that some of the names that are found in our raw data may not appear in our supplemental data, which creates a huge percentage of lost data. In addition to that, our Python code is not able to parse multiple last names, such as de la Paz, which is 3 words considered as one. Therefore, we need to reconfigure that to account for all of those last names and whatnot. And from there, we can then analyze the results from all counties in the Florida to really begin identifying those Hispanic voting trends from a map. And it will also give us a variety of other statistics that we can use to then really help certain Hispanic subgroups participate in voting, because we know that not all Hispanic subgroups participate in voting equally. And in addition to that, we can also use this type of model to analyze other types of minority groups if we would like to. That will give us even more additional information about how America or certain states participate in their voting for local and national elections. If you have any questions on my research, please feel free to reach out to me. And other than that, thank you for listening to my presentation. Thank you.